right, let's talk about hydrogen fuel. So hydrogen fuel is very new and it's a little confusing. So I've included some videos to watch. So check our calendar out and look at that little section. So here we go. Okay, so hydrogen can easily store, transport this source of energy. We can use it for both cars and as an electricity source. It is kind of cool because my dog's barking. Because you can look at a windmill, produce electricity, and you can use electricity through this process called electrolysis to split water, H2O, into hydrogen and oxygen. And this hydrogen is what we're interested in because that can then go through the process of this hydrogen fuel cell to make electricity happen. And then when it's done with that process, it becomes water again, and that's the only waste product. So it's kind of a very crazy technology and amazing. From the car perspective, we've got the electric car, which uses this lithium ion battery. This whole bottom of the car is that lithium battery. It's very heavy. Lithium has to be mined. There's a whole environmental component to that, and it still has to be plugged in, and it uses electricity to charge, which may or may not be from fossil fuels. The hydrogen fuel cell, you pump this hydrogen, like down here, stored in these tanks. You pump it in, so you fill it up kind of like a gasoline-powered car, but you're filling it up with hydrogen gas, weighs way less. Look at the battery size comparison. And then you've got the hydrogen tank, the fuel tank here, and then the only waste right here that comes out the back of the car, water. That's crazy. So a lot of people, environmentalists, like true environmentalists, are thinking maybe this is the way to go. Right now, the Nissan Leaf and the Toyota Miura, I think is how it's spelled, are the only two hydrogen fuel cell cars. Everybody else went lithium battery. So we'll see what happens. Okay, so how do we get this hydrogen fuel thing? Well, anything that can help us extract hydrogen. So natural gas is CH4 or methane. So you can combust that or burn it and take the hydrogen off of it. You can get it from biomass. There's bacteria that can isolate the hydrogen. You can get it from solar, you can get it from wind, and you can get it from nuclear. When I say you can get it, you go through a chemical process of stripping out the hydrogen atom to its form of a hydrogen ion. And then the hydrogen goes through this process where we send the electrons through the cathode, and this is a circuit, and then to the anode from the negative side to the positive side. And this is the little zappy thing is what we're making work with electricity. Then the hydrogen will come back in here. Oxygen comes in from the air, and we put it back together to make this water thing. So that's electrolysis. So that's how we kind of stick it back together or get the hydrogen, but then the reverse process makes the hydrogen fuel cell actually work. So it's pretty tricky and clever technology. And the trick is just deciding which source to get it and what's the most efficient cost-wise to make this happen. So, slow story. The hydrogen comes in from the air to the anode. The atom gets stripped, so we have our hydrogen ion here, which is able to pass through this membrane because the positive charged atom can go through, a negative charged one cannot. The negative electron goes up, powers whatever it's going to power, comes back down inside to the other cell. So it goes around the membrane, whereas the hydrogen atom can go through the membrane. Oxygen comes in, combines with this hydrogen atom that passed through, and water comes out. That's it. And that whole little circuit, while this is going on, of moving electrons, makes the electricity. And that's how that fuel cell works. Pros and cons. All right. So it is renewable. That's awesome. It actually works in tangent with other renewables because you have to do this electrolysis process to get the hydrogen atom isolated. You can use the electricity driven from wind or solar power to do that. It can help us meet during peak electricity demand time. In the long run, it's going to be inexpensive. It's really expensive right now, but when we get the technology handled, it'll go down. We can produce it domestically. We don't have to depend on foreign countries for it. And you can even, water is a waste product, so we can use that for, irrigation. How awesome would that be? So there's some environmental impact depending on what we are using to get the hydrogen and how to extract it. So again, remember methane's a greenhouse gas, but if things are just decomposing like in the landfill or whatnot, we can take what's going to be methane anyway, or the cows out in the pasture, and take that methane and use it so it's not going into the atmosphere for global warming. It is costly up front. Where are we going to store it? So there's a lack of a reservoir for it. That's something we can build in time. And then it also relies on the water cycle and local hydrology. So if there's not enough water around to make this happen, it could be a little challenge. So now you're going to start hearing these terms of hydrogen and some colors. So gray hydrogen implies that we're getting the hydrogen by combusting fossil fuels, probably natural gas. Blue hydrogen is kind of the same, but we have this little storage additive, so it's not as horrible as the gray hydrogen. And then green hydrogen refers to we're using wind or solar power to extract that hydrogen atom and make it a cleaner, more environmentally friendly way of getting the hydrogen. And then that way it's like 100% renewable and sustainable. So that's the hydrogen fuel cell. Enjoy.